Okay, let's take a look at 3b. So in 3b, I have another logarithmic equation, but this time I can tell I'm not going to be able to do what I did in part A. I don't have a single log on both sides of the equal sign, and I don't want to move one over if I don't have to. So because I don't have a log on the right side of the equal sign, it doesn't mean I can't solve this. It just means I have to solve it a different way. So first thing we're going to do is, before we worry about converting logs to exponential functions, I still want a single log over here on the left. So I'm going to combine these two logs together. And because I have two logs with the same base, they're both base 2, that are being subtracted, my property says I can combine these into a single log by division. So I'm going to combine the left side of the equation so that it becomes log base 2 of x plus 4 divided by x minus 1. So log base 2, and in parentheses, the first term, the x plus 4 goes in the numerator, the x minus 1 goes in the denominator, and I set that equal to 3. So I have a single log on the left side, no log on the right. Now what I want to do next to solve this is I want to remember how to convert a log to an exponential function. So when in doubt, convert logs to exponential functions. Just a kind of a good rule of thumb. What does that mean? Well, do you remember when we first learned about logs? And we said, okay, let's say I have a log base A of y is equal to x. All a log really is an exponent. This is really saying a to the power of x is equal to y. Oops, a to the power of x is equal to y. So if you just remember that little Ferris wheel cycle, start with the base, go to the other side of the equal sign, and then come back around and you'll set it equal to the value you're taking the log of. So a to the power of x is equal to y. So if I do this down here, I'm going to start with the 2, set it equal to, raise it to the power of 3, and set it equal to this fraction. So 2 to the power of 3 is equal to x plus 4 over x minus 1. Okay, now comes the hard part, solving it. All right, we can do it. First thing, 2 to the power of 3, that's just 8. So let's go ahead and write that in. Okay, this is where our algebra skills are gonna come into play. So in order to get a single x by itself, I have to work with this fraction. I can't just cancel things. Nothing here cancels. What I want to do is multiply both sides by the denominator, that x minus 1, so that the denominator will cancel on the right, and on the left I have x minus 1 times 8 is equal to x plus 4. Keep doing algebra. I'm running out of room, so I'm just going to go down to the next part. We'll just continue. Pretend 4 isn't here. Going to multiply out the left side. So x minus 1 times 8 would give me 8x minus 1. Or sorry, 8x minus, 8x minus 8, excuse me, is equal to x plus 4. To get x by itself, I'm going to combine the x's. So I'm going to subtract the x from the right side, move it to the left. That will give me 7x. And then I'm going to add 8 to both sides to get the 7x by itself, and that gives me 12. The 4 plus 8 is 12 on the right. Divide both sides by 7, and I'm left with x is equal to 12 sevenths. Now, are we done yet? No, we want to check this. Remember, just like we did in the first problem, 3a, we want to make sure that this is a valid solution. So, if I plug in, if I plug in 12 sevenths into the original equation, do I end up with positive values? So log 2 of 12 sevenths plus 4, that checks out. Log 2, 12 sevenths minus 1, that checks out. So check to make sure it's valid. It is. That means 12 over 7 is my one and only solution. Great job.